Hello and welcome everyone. So I'll be explaining you Codeforces GoodBye 2020 problem C Canine poetry, right? So this problem the statement actually says that we're going to be given T strings, and for each of the strings, you have to find out the minimum number of changes you have to make the given palindrome with having no or containing no any um, containing no palindromic substrings of length greater than 1. Okay, let me give you an example. A, B, B, A, T. As you can see, we have already found out one palindromic substring, right? This is a palindrome. This is a palindromic substring. And this is also a palindromic substring, right? So we have to just somehow find the minimum number of changes. We could change any character any number of times. Okay, so we need some observations here to make that possible in a minimum number of way. What could be that observation? Let's see. So there's one observation is that if any palindrome, let's say we have a palindrome of length 1, 2, 3, 4, 5, 6, 6 length palindrome. Let's say this is a palindrome here. If this is a palindrome, then this is also going to be a palindrome. Okay? If this is a palindrome, then this is also going to be a palindrome. So this is palindrome's personal property. Okay? This is its own property that if a string is a palindrome, okay, if we can call it as a palindrome, then the string, by reducing it to like this as I showed you, this will also result as a palindrome, because without this big string can't be palindrome. So if you somehow find the root palindromes of a big palindrome number, palindrome string, if you somehow find the root palindrome, and if you change the root palindrome's character, root palindrome meaning by the smallest length palindrome between inside the big palindrome, which is for even length. Let's say n is even, okay, n is even, then its root palindrome will be of length 2. Okay, for this problem, as they're telling us to find out greater than 1, no greater than 1 palindromic substring need to be added. So for n length even, we can find its root palindrome as a 2 length palindrome, right, where these values and these values will always be the same, right? And for n equal to n equal to odd, if n is an odd number, then its root palindrome will be of length 3, right? So this is a general property. I'm telling you, if I somehow change the characters of root palindrome, it will have a very big impact on the um, larger palindrome length, which is actually uh, just outside of the root palindrome, right? So that's the key observation. So we have for n equal to even, for n even, we have 2 linked palindromes where two characters are equal, and an even linked palindrome where this value could be something and this will be equal, right? So that's the key observations you need to follow, because I'm repeating it again. Okay, if I change the root palindrome's character somehow to something, because I will always have uh, other choices no matter what happens. Okay, I will always have other choices. If you analyze it, you will understand that. So our task is to find out the root palindromes and change those characters of root palindromes so that it will have a very big impact on the larger palindromes, and our and finally we will get a minimum number of finally we will get our result in a minimum number of ways, minimum number of steps, sorry. So that's what it is, that's what we have to do. Let's take a look at one example here. Let's take BA. Okay, this is it, this is the example. Okay, let's say BA. So they're telling us that this has answer is 1. Why its answer is 1? I'm telling you. Okay, let's have a deep analysis on that example. BA. Right, let's see. BA. You can clearly visualize that I have lots of palindromes here. Okay, let's take it out. Which are the palindromes? This is a palindrome. This is a palindrome, right? This is also a palindrome. Okay, so we're getting what? 3 palindromes. Do we really need 3 steps? Or we could do it minimum ways. Let's try to find out that too. If you slightly analyze it, you will find out that, okay, how about finding the root palindromes? Let's try to find out the root palindromes. Remember what we said? We have 2 root palindromes. One is odd length, which is 3 length root palindromes, and one is even length, which is 2 length root palindromes. Okay, so even length palindrome would look something like this. This is an even palindrome. This is a root palindrome. We could say this is a root palindrome. Okay, so we will, when we traverse, we will easily find out. Let's say we are traversing. We're finding out this, and we are each time we're checking whether it is a root palindrome or not. I'll show you how to check if it is a root palindrome or not. If it is, we're just sure that this might have a very big impact on that. Okay, so we're here finding a root palindrome here. Look, there is a root palindrome here. Oh, one thing to notice that if I will always change which character of that root palindrome. This is a very important aspect. This is a very important important part of it, because, sorry for the sound, um, we will always try to change the rightmost, the root palindrome's rightmost position. We will always try to change that, because it will always help. You can draw some test cases. You will find out that always changing the rightmost characters of the root palindromes will give us the optimal result. So that's why we're going to be only, look, if for this character, I'm knowing that, okay, this is my root palindrome, I will always change this character, which is the rightmost positions of that root palindromes. Now, how do I change that? Which character do I change? I will always have, remember, I will always have one choice which make a difference, which will make a difference. So let's take any characters. Let's take hash, and just to set the values here, just to make sure, just to keep track on, we're just keeping just hash, because we will always have any number of any of the characters. We're not just jumping onto other ABC characters just for the sake of tracking. We're just inputting the hash value. Hash character. Let's jump into the code part. Well, I will show you how we did that. So we're taking the test case, and then we're taking the strings and finding the length of the strings. If the length is 1, answer is 0. You know it, because there is no other palindromic substrings here. And here is the fun part. For what about this loop? What are we doing in this loop? In this loop, we're checking if si is equal si minus 1. We're checking what? The root palindrome, root even palindrome, right? Root even palindrome, right? This is by doing this line. And also we are also checking whether si minus 1 is not equal to hash, because if it is equal to hash, which does indicate what? we have made it already. We have changed that character already. We don't need to do that. So we're just this is an extra check for that. And if it is satisfied that we have found out the even palindrome, I mean even root palindrome, we're gonna be changing the rightmost characters. That's exactly what I'm doing. Si equal to hash. And what about the next case? Also we're checking both. Okay, at the same time we're checking both. Then this is for the odd length palindrome, root odd length palindrome. Okay, root odd length palindrome by checking si, if whether si is equal to si minus 2. And also the same thing, whether it is already calculated, whether we have already changed that character or not. So if that condition also fulfilled, then we're gonna be assigning the hash value just to make the track that yes, we already did that step, and also counting the minimum number of positions here. Rest plus plus is actually calculating the steps. And finally we're going to be just outputting the statements, the final result. So that's how we're going to be doing this problem. I hope you understand, and till next time, goodbye.